In our universe, all things are driven by energy. Energy powers our sun, our environment, our society, even our bodies. Energy is life. New and profound advances in science and engineering are allowing us to harness this energy abundance in marvelous new ways. To create clean, affordable, and reliable energy for all Californians. The SoCalGas Research Development and Demonstration Program has enlisted an incredible team of experts in science, engineering, industrial technology, and environmental policy to identify, build, and implement these transformational technologies throughout society. Collaborating with the world's top institutions, we have deployed over $73 million on hundreds of groundbreaking projects over the past 5 years. Hyatt Hydrogen, which could enable transporting hydrogen through existing infrastructure to power fuel cell vehicles and facilities. Doosan Mobility Innovations hydrogen drones that have 4 times the flight capacity of lithium-ion powered alternatives. And hydrogen-powered yard trucks that can move massive shipping loads for 20 hours per day with 0 emissions. These revolutionary projects are saving energy, reducing emissions, and improving air quality, as well as increasing energy safety, reliability, and affordability for all. At SoCalGas RD&D, we believe in clean energy abundance, so we are sharing this pivotal research in order to deploy these innovative technologies across the world. Because energy is life. And we believe a clean energy future will bring a better future to everyone. SoCalGas, Research, Development, and Demonstration. Learn more at www.socalgas.com/RDD.
All right. Good morning, everyone. Welcome to another SoCalGas RD&D research webinar, and thanks for taking time out of your busy schedules to tune in today. My name is Jeff Chase, and I am the Clean Transportation Program Lead on the SoCalGas Research Development and Demonstration, or RD&D team. And for today's webinar, we will be welcoming Bart Sova from GTI Energy to discuss the hydrogen fuel cell yard trucks at the Port of Los Angeles, which was actually one of the projects mentioned in that opening video. Before we begin, I just want to walk everyone through the GoToWebinar toolbar that should be visible to all attendees. Please enter any questions in the questions box. We'll review them during the Q&A session after the presentation. And during the Q&A session, we'll also open up the discussion for verbal questions. Click the raise hand icon to be called on during the Q&A session. And when you are called on to ask a question, we'll first grant you access to unmute, then you must manually unmute yourself. Please go back on mute after asking your question. And please note that you may have to change or update your computer settings in order to enable your microphone. So please take a moment now to check those settings if you'd like. And finally, you will find a few very valuable documents in the handouts box, also on the toolbar. So first, I just want to share our commitment to the community. At SoCalGas, our commitment to provide customers with safe, affordable, and reliable service goes beyond natural gas. We are also dedicated to improving the quality of life in the diverse communities that we serve. And to support this commitment, RD&D staff conducts activities to engage with community-based organizations, or CBOs, in our service territory and throughout California. We notify researchers, entrepreneurs, and businesses from ESJ communities about research funding opportunities, whether from SoCalGas RD&D or any of our other research partners. We also share results from RD&D projects to inform and educate the general public, and we track and report progress of equity engagement efforts in our annual report. Just to give you all a quick overview of how our research program is structured, the SoCalGas RD&D program is divided into 5 areas that span the entire energy supply chain. So on the upstream side, low carbon resources focuses on renewable gas production, such as RNG and hydrogen. The gas operations team focuses on new pipeline technologies. And then downstream, the clean transportation program focuses on on-road, off-road, and refueling station. Clean generation focuses on distributed power generation as well as microgrid technologies. And customer end use applications focuses on thermal applications from residential to commercial all the way up to industrial scale. In 2022, the SoCalGas RD&D team managed 339 research projects. And on average, our RD&D projects generate a 7.2x funding ratio, meaning that for every dollar of RD&D funding provided to a project, the project also received over $7 of external co-funding. So for example, in 2022, 8 of our RD&D supported projects were awarded about $18 million from the California Energy Commission. If you want to learn more about the RD&D program, please check out our 2022 annual report, which is included in your handouts today. We've also produced a Spanish version of the annual report to better connect with the diverse communities that we serve, and the Spanish version of the annual report is also included in today's handouts. And both copies are available on our website in case you want to check them out in the future. And finally, we just want to stay connected with our stakeholders in the research community and the general public. So please visit our webpage where, again, you can find our annual report, but you can also find information about upcoming webinars, news about the RD&D program, and then also please reach out to the RD&D team via email with questions, comments, or research suggestions. We also maintain an RD&D page on LinkedIn and on the CEC's research networking platform, Empower Innovation. Now, without further ado, I just want to introduce Bart Sova. Bart is a research and development manager at GTI Energy, a leading nonprofit research and training organization that is focused on developing, scaling, and deploying innovations that support low carbon, low cost energy systems. Bart is focusing on the decarbonization of the transportation industry by helping fleets, truck manufacturers, and technology developers evaluate new technologies through pre-production demonstration projects. He is managing projects showcasing technologies and vehicles such as the hydrogen-fueled switcher locomotive, hydrogen-fueled terminal tractors, 500-mile hydrogen-fueled Class 8 tractor, and developing a blueprint for a Houston to Los Angeles hydrogen corridor, and more. Bart has over 18 years of experience in mobility and energy industries, and prior to joining GTI Energy, he worked for Navistar and Mitsubishi Heavy Industries. So welcome, Bart. Thanks for joining us, and I'm excited for you to share the results of this great project with our audience. So I'm going to go ahead and turn over the controls to you so we can get started.
Thank you, Jeff. Thank you for the introduction. Good morning, good afternoon, everyone. I think we have folks coast to coast. Again, thank you for the opportunity to showcase the work. And I'd like to thank SoCalGas for being a continuous supporter of technology development, especially in clean mobility space. I will turn off my webcam so we're not consuming the bandwidth here, and I'll just move into our presentation. So I'm here to talk about a project that was co-funded by SoCalGas and California Air Resources Board and also the project partners that started about 5 years ago or so. And we just wrapped up 3 months ago. So we have some great lessons learned. And maybe I'll just start by quickly introducing GTI Energy for those of you not familiar with us. We like to keep a low profile. as Jeff mentioned, we are a nonprofit research and training organization focused on developing, scaling, and deploying energy transition solutions. And in that endeavor, we leverage the expertise of our trusted scientists, engineers, and partners in collaborations that deliver innovations needed for low carbon, low cost energy systems. That's how we all like our energy, right? We like it clean, cheap, and safe, and that's what we try to do. So GTI Energy is an independent nonprofit founded in 1941. We are technology agnostic. As a nonprofit, we don't make or sell anything, and our mission is to advance technologies from the lab closer to a commercialization space or to the market. Formerly, we have been known as GTI or Gas Technology Institute. We are headquartered in Chicago, or in just outside of O'Hare Airport, where we have close to 20 acres of labs and research space, and a couple hundred of our researchers are here in the Midwest, but we have a total of about 500 people corporate-wide, coast to coast, in 12 locations. And we work across the whole energy value chain, from exploration, production, distribution, through end uses. My focus is on transportation or mobility technologies. And specifically in the last few years, we've seen a lot of exciting activities and movement in hydrogen mobility or hydrogen powered mobility solutions. And here on this slide, you can see some of the examples of the projects that we work with and demonstrate and help technology developers or manufacturers develop and demonstrate them. So you see the Doosan hydrogen drone that Jeff had in the video before, and our hydrogen yard truck. We had some hydrogen drayage trucks that we've deployed, and we're also working on hydrogen switching locomotive. You see one of the early designs in the bottom right corner. And we get this question quite often. Why hydrogen? And it's because it's a great energy carrier that can help us transition from diesel. And hydrogen can and will play a very important role in difficult to decarbonize applications. Basically, where the battery electric vehicles hit limitations, that's where hydrogen will really be beneficial. So it will enable long endurance. It will offer weight benefits or cargo benefits. It offers multiple shift operations, and you can also operate hydrogen vehicles without any wired infrastructure, such as charging infrastructure. So again, a lot of these aspects are very attractive to cargo handling applications and port operators and rail yard operators. And we see a lot of exciting work and technology coming up that will enable this transition. So before I go into technical details, I'd like to also recognize our sponsors and partners here on this project. So like I said, the project started, the concept was developed in about 2017. So when you think about it, it's 5-6 years ago. The capacity trucks team already had the vision of developing and deploying fuel cell powered yard tractor. The the project was funded primarily by the California Air Resources Board with significant support from SoCalGas. So again, I'd like to thank our sponsors here. You can see the NASCAR slide here with logos of our project partners. We had a very strong team that overcome multiple obstacles, including COVID and permitting delays and supply chain disruptions. Nevertheless, we succeeded. The project wrapped up, like I said, wrapped up 3 months ago, and we have some great lessons learned that I will go through at the end of my presentation here. So, for the technical details, the interesting stuff. The yard tractors are vehicles that have very specific application, moving cargo containers and chassis around the yards, typically move at low speeds. They have short wheelbase to enable high maneuverability. They have great visibility out of that little cab, and they typically do not require large powertrains because they don't have to move fast. So here you can see that our yard tractor had about 200 kilowatt traction motor, which even with 200 kilowatt output, that tractor could move easily 150, 200,000 pounds if needed. We had 85 kilowatt hours of battery storage on board and 9 kilograms of hydrogen storage. There were quite a few trade-offs, technical trade-offs that we've had to make due to packaging constraints, supply chain challenges, and performance requirements. The team went through 7 iterations of the configuration. And as you can see, it is a really tight package. I guess one of the major trade-offs we had to make was the onboard hydrogen storage. We were hoping for more hydrogen on board. We could not find space at the time, given everything else we had to put on the chassis. So we ended up with 9 kilograms. However, that proved sufficient. Before I continue with the slides, maybe I will showcase the video of the truck itself and the operation as well. That can probably answer a lot of questions in advance. And let me see if I can switch it to video here.
Every day, more than 25,000 shipping containers arrive, leave, or move at the Port of Los Angeles. Yard trucks are the workhorses that transfer containers between the dock and the drayage trucks. About 1,000 terminal tractors operate 24/7 and emit about 80,000 tons of CO2 annually, which accounts for almost half of all CO2 emissions emitted by cargo handling equipment. The California Climate Investments ZCAP, Zero Emissions for California Ports, project managed by GTI Energy, is putting cap and trade dollars to work to demonstrate fuel cell yard trucks through the rigorous duty cycle at the TraPac terminal at the Port of Los Angeles. 2 plug-in zero-emission Class 8 trucks, built by Capacity Trucks, BAE Systems, and Ballard Power Systems, are moving heavy containers from dock to port gates. Once a day, the trucks stop at the hydrogen station developed by H-Tech and Zen Clean Energy to refill the tank. Fueling is done quickly, which is essential for a busy operation. Yard trucks are the single largest source of emissions in all classifications of cargo handling equipment and are difficult to convert to zero emissions due to their unique duty cycle and their requirements for power, versatility, and durability. ZCAP's deployment of fuel cell electric hybrid yard trucks is delivering insightful information to validate the vehicle's commercial viability. GTI Energy and Frontier Energy, with the support from SoCalGas, are collecting data that is demonstrating that fuel cell powered yard trucks are safe, reliable, and operationally preferable to diesel equipment. This will inform design of a next generation fuel cell yard truck that is a step closer to commercialization and stimulate adoption of other clean heavy-duty vehicles. The ultimate goal is to replace all 1,000 combustion engine yard trucks that operate at the Port of Los Angeles with zero-emission vehicles, which will significantly improve air quality and reduce noise pollution for the people who live near the busy port and workers at the port facilities. The $12 million ZCAP project funded by California Air Resources Board is part of the California Climate Investments. ZCAP will generate increased awareness of hydrogen as a viable clean energy source and showcase fuel cell vehicles as an excellent technology solution to support net zero emission goals.
All right. So I think that video really does the best job I could think of presenting the intent and the opportunities for the technology. And also it shows you the environment at the port that I was surprised how busy and how difficult it is to manage that operation. So I'd like to credit all the folks that are working at the ports moving the cargo there. So going back to our design here, the key aspects are really, or the questions that we get the most often are around the hydrogen storage and the hydrogen systems. And like I said, on the truck, we managed to squeeze about 9 kilograms of storage. You can see these 2 cylinders, they are about 103 gallons by volume. They weigh about 350 pounds, and they can be filled in 10 to 20 minutes, depending on the conditions. And then the tanks were filled from an on-site fueling station that was developed, designed, and built by H-Tech. We had about 180 kilograms of onboard storage in a cascade system. So these are just tube tanks, and the system, due to well, complexity and budget limitations, was purely manual or analog. We did not have any electronic controls. Only 120 volt circuit was required to power safety equipment and detection equipment. And we've learned quite a few things when operating and deploying it. The fueler and actually any infrastructure planning turned out to be more complex than we anticipated. The team went through several potential locations for the fueler and completed the site plan that accounted for any safety setbacks required, any barriers and fencing that was required to protect the station. It also accounted for fuel delivery routes from outside, bringing the hydrogen to the site, any logistics associated with that. We went through permitting with 3 agencies. Again, I guess permitting hydrogen at the port is as difficult as it gets. So we worked with 3 agencies here, LA Building Department, LA Fire Department, and also Harbor Department. We conducted a lot of coordination meetings with the authorities having jurisdiction here and first responders. The commissioning of the system involved also fire department, as well as safety training of both personnel operating the equipment and the fire department, so they know how to respond to any potential incidents. And then HTEC supported the fueling station with maintenance of the hardware. The trucks were operated for about 12 months. We had a few interruptions due to programming or software with the vehicles and a couple of other issues, but in general, the trucks were very reliable. We did not have any hardware failures. There was a recurring concern from the operators about the feel of power steering system, which was traced really to programming of the controller, and it largely addressed it. But otherwise, it was very successful. The trucks were used in support duty, which was a little unique for TraPac, our terminal operator here. Their terminal is highly automated, so the trucks, the yard trucks, they don't really move the bulk of the cargo, but rather move specialty containers or other equipment. So that duty cycle was possibly a little bit lighter than distribution centers or other terminals. Nevertheless, the trucks performed really well in this setting. We did find that collecting data from these prototype vehicles and these novel powertrains can be challenging. So the telematics are harder than we anticipated. The data of our quality could have been better, but we did get what we needed, and we did learn a lot. Now, I think one of the most important outcomes of the project, what is that we really learned? The first thing is performance, and this is a little bit of a busy slide, but we found that the vehicles consumed on average about 0.7 kilogram of hydrogen per hour, which compared to baseline diesel consumption of 1.25 gallon of diesel per hour. If you look at the energy efficiency, the hydrogen truck was 67% more efficient than diesel. So this is already a great success. As such, despite our concerns with lower than anticipated onboard hydrogen storage, the trucks could operate for 2 shifts continuously if required. In practice, we didn't see too many back-to-back shifts, but given the amount of onboard energy between hydrogen and the battery, the truck would have made those 2 shifts or 17 hours. And here you can also see the benefit or the advantage of hydrogen, where we had a total of 340 kilowatt hours of usable energy on board, which I don't think you could physically pack this many batteries on board if you really needed to. And then the second biggest benefit of using hydrogen in this application is that you could and you can refuel the truck in 15 to 20 minutes. So whether it's a quick top off in between first and second shift, or whether it's at the end of the second shift, or again, if it's in the morning before the first shift starts, you can really keep these trucks running almost 24/7 if needed, which that can be difficult to accomplish with plug-in battery electric trucks, where you do need some dwell times just to charge them. Overall, the trucks performed really well. The drivers like them. In essence, they are electric vehicles, right? So it's the instant torque, it's the quiet operation. There's no vibration. There's no diesel smell that the drivers appreciated. We do hear that quite often, that you know, folks working with diesel equipment, they bring that smell home, and here the problem was solved. So they appreciate that. The capacity team did a great job validating and testing the performance. On the left photo here, you can see how the truck was tested in Texas, just pulling test trailer with weight to make sure that it can stand up to the demands and the duty cycle at the port. Another thing that the drivers appreciated was a familiar interface. So we did not have any fancy yokes or 17-inch screens. It still looked like a truck inside and had the same controls. The only two differences really was regenerative braking control. There's an additional dial numbered 11 here on this slide, if you can see the detail, where they could adjust the amount of regenerative braking, which again they really liked, because after probably half a shift they would not touch the brake pedal at all. They did like that. And the second novelty item was number 15 here, which is a small display showing the status of the electric powertrain. And overall, the drivers liked it a lot, and we couldn't get enough of the compliments. The next lesson learned that we had was our fueling experience. And the first I guess lesson was that the cascade fueling system that we have deployed, while it was cost effective and lower complexity than comparable permanent stations that would have on-site liquid storage and maybe some compression, it was still limiting the operation if it was multiple vehicles and really mission critical operation. The fueler that we have here, and you can see on the right hand side, you can see the control panel. Since it's all analog and mechanical, it required some manual operation from the operators to complete the fueling process. And cascade filling relies on switching banks from the lowest to highest pressure. And what we found is, despite training, there were still issues with following the process. So the filling was not as effective as we had designed it to be. And you can see it on the chart on the left-hand side. As the fueler was getting depleted, the truck was getting on the partial fills. So for example, arrow number 1 here, it shows the truck. So the orange line shows the fuel pressure on board of the truck. The first fill, labeled number 1, fueled the truck to 70%. But as the pressure in the fueler dropped, those fills, the duration of the fill was getting longer and longer, and the operators and the drivers, they were losing their patience, and in essence, the truck was getting incomplete fills. Not ideal, and there are solutions out there where the cascade filling systems have some automation that overcomes this limitation. Nevertheless, we found that this was a bit of an issue here. So for the purpose of this demonstration, 1 or 2 trucks and the budget constraints, it was still okay, but likely for a application that requires more trucks or more effective fueling, another solution would have to be considered. Other things to consider here when planning fueling of hydrogen trucks. So the cost and availability can be a challenge. We've had a great partner. So HTech partnered with Air Liquide, so we did not have issues with hydrogen supply and cost. But we've heard from other operators in different vocations that it can be a challenge. So obviously, if you are planning on deploying hydrogen equipment, make sure that you find a reliable partner and you have a good commercial arrangement for the delivery of hydrogen. Another thing that we've learned is that for the off-road or cargo handling equipment, and I'm guessing also in agriculture or construction, wet hosing or practice of bringing fuel to the vehicle or to the equipment is preferred over using a fueling island. These are slow-moving pieces of equipment, and it just takes time driving there to the fueler and back. So again, here for 1 or 2 trucks, it was acceptable, but when you look at the photo on the bottom, it shows a parking lot or a corral for ER trucks. This is at a different terminal operator, and you have probably 20, 30 trucks that need to be fueled. Ideally, a fueling truck pulls up in between those vehicles with a long hose, and they fuel them one by one, so they can top off all the vehicles in a matter of 2 hours or so. Now, if they had to drive them across the lot somewhere and fuel them one by one at the fueling island, that's a operational inefficiency. So that's something to consider. And we see a lot of exciting work happening right now in the industry, developing those mobile fuelers that can do back-to-back dispensing. So we expect that broader adoption of these hydrogen powertrains will have less obstacles moving forward. The cost and complexity of a fueling station, again, these things are not cheap. So the more vehicles you have and the more demand you have, the better it is to invest in a large and reliable solution. Again, you have to do the math and analyze your operations thoroughly to make sure that you get what you need to support your business, especially when it comes to back-to-back fueling. Hydrogen dispensing, especially at high flows and pressures, can be challenging, and some of the fueling stations, those of you that maybe drive the Mirais and light duty vehicles, you probably might have witnessed some time needed for the station to recover from previous fill and pre-cool the gas again. So there's a lot of things to consider here. There's not one solution that will work for all, and it just requires some analysis and planning to get it deployed effectively. Another thing that we've learned is misconceptions about hydrogen are rampant, and the photo here, it's a little bit of a comic relief, but despite the safety trainings we have conducted, there was still apprehension from the workforce towards the hydrogen, and possibly it was a little unsubstantiated. However, we did go through a lot of education, even though we covered everything we thought was important for hydrogen safety. The staff was still concerned with PPE, and at some point they were considering wearing hazmat and Nomex suits, which were provided, only to be never worn, because they did it 2 or 3 times and realized it's not any harder than using propane. And you see the guy in a go-kart here with a propane tank being a little cavalier, and that's the analogy that we like to bring up very often. When was the last time you were concerned with the propane tank in the back of your truck coming back from Home Depot? And hydrogen is not any different. Of course, it's a volatile, flammable, compressed gas, but it's been around, the technology has been around for decades, and there's a lot of safety standards and codes and procedures that ensure safety. As long as they're followed, it is as safe as any other fuel. Actually, that's part of the presentation that was used in our safety trainings. This was prepared by HTech, just showing the comparison of hydrogen hazards when compared to natural gas and gasoline, and you can see that it's very comparable. As long as the protocols and safety procedures are followed, and there's all the required safety equipment. You can see the types of safety devices and equipment that's used with these hydrogen fueling stations. It is absolutely safe, and there's nothing to be concerned of. However, it does need a lot of education and kind of dissolving these misconceptions. Finally, and this is probably the most important and the most exciting learning from the project, is the capacity trucks team. They were so satisfied with the design and performance, and also they had such a big interest from the industry that they developed a second generation truck based on the 2 prototypes we've ran. They partnered with Hyster, developed a new cab that allowed them to organize the components better. The components are laid out differently. They changed some of the parameters. They also built the truck in 2 versions, with fuel cells and with battery electric configurations, and they're going into production. I spoke with them a few months ago, and they were expecting to have these trucks commercially available, I think late in the summer. For those of you that were at ACT Expo in Anaheim a month ago or so, one of these trucks was on display there, and we're really excited for them to bring this to market in volumes. what's next? What do we see next in the industry and in this space? So the first thing is that the cost of these technologies and vehicles will keep improving, especially the expensive and core technologies such as batteries and fuel cells. They will keep coming down as the volumes grow. I don't expect them to be on parity with diesel. I don't think that will ever be the case. But if you start looking at levelized cost of or total cost of ownership, at some point they will hit the cost parity there. Not hardware, but overall cost of operation. We see that the industry is continuously improving and developing electrified components. So where we started 5 years ago, there were very limited choices for accessories such as air compressors and power steering pumps and axles and so on. It's more and more. You see them commercially developed, mature, with improved cost and efficiency. So that will definitely play a role in the next generations of designs. Another thing that we see need for is to keep the incentives coming from the government agencies to help offset that incremental cost of hardware. Again, it will be hard to produce these things at the same cost as diesel trucks, and that's what makes it hard to really wean ourselves off of diesels. So there will need to be rebates and vouchers such as the CARB program or maybe the DERA federal programs that will help offset the cost of transition to the hardware, to the new hardware. We do expect the cost of hydrogen to come down, and it is coming down, especially in light of the investment from the agencies, from the government agencies, especially the Department of Energy's hydrogen hub investment of about $8 billion, and the hydrogen shot goal, which is a roadmap from the Department of Energy to enable the industry to produce hydrogen at a cost of $1 per kilogram in 2031. So that will be a key factor in the total cost of ownership parity with diesel, getting that hydrogen cheap and clean. We do see the technology improving for the fueling solutions. As I mentioned before, the cascade filling can be limiting, but we see a lot of exciting technologies being developed and demonstrated, including faster fills. So there's a lot of industry effort in developing 10 kilogram per minute filling technologies and protocols. So when you think about it, you could fill a tank on this yard truck in a minute, which is on par or possibly even faster than diesel fills. We do see, another thing we see is operators of the equipment considering co-locating other pieces of hydrogen equipment together. So if there is investment in the fueling infrastructure on site, the more equipment is using that hydrogen, the more hydrogen is being moved and delivered to the site. The levelized cost of operation of that hydrogen goes down. So again, for any those of you considering transition to hydrogen, look at the other equipment that you can convert. We see that again at the ports, whether it's RTGs, the rubber tire gantry cranes, or top handlers and stackers, and yard tractors, forklifts, the more equipment you have running on hydrogen, the easier and cheaper it will be to fuel them in the long term. Workforce development and education. We see quite a bit of miseducation, misinformation, and also apprehension towards the new technologies. Some of them are just due to fear of losing jobs. Sometimes what we hear is that the drivers or mechanics are concerned that these new technologies will be automated and they will require less maintenance and support, and therefore they will lose their jobs, which is not the case. They do need to get probably retrained, but we all do. So I think it just requires constant outreach to the communities, to the creation of the education programs and college curriculums to keep the workforce excited and moving in that direction. We also expect, and we do see a lot of grants coming towards more demonstrations like this. These are critical. These grants and these incentives are critical in bringing those expensive pilots and prototypes to the industry and showcasing them. It's really hard to ask a business to fork out hundreds of thousands of dollars on a piece of equipment that may work or may not work for their needs. So these demonstrations are very important, and we do learn a lot. Again, we appreciate the agencies sponsoring these activities, as well as industry partners like SoCalGas helping with these. And my final point here, this is answering some of the questions we've seen in other forums and coming from Q&As, whether the hydrogen is green or not, and whether we use the green hydrogen. And I'd like to just make a statement here that the idea of hydrogen colors is absolutely irrelevant. It is a nice and convenient simplification of a very, very complex question that doesn't really address the core issue. And it comes down to carbon intensity of the energy that is being used. I'd like to bring this analogy of nutrition labels on food. Just because the label on the packaging says that it's healthy, it's meaningless until you look at the details. That's why FDA required those nutrition labels to be included with all the products. Similarly, hydrogen color is meaningless because you cannot compare it to anything else. The electricity is not categorized in colors, and diesel is not categorized in colors. And really having a color label assigned with hydrogen does not help anyone. So if you do have questions or concerns about sustainability of the fuel or energy that you're using, I encourage you to look for the carbon intensity values instead. And you can buy energy that's cheaper or cleaner, or whatever requirements you have for your sustainability goals. And that's the end of my presentation.
Awesome.
I guess, Jeff, I don't know if we've had any questions.
Oh, we've got a lot of questions. Thank you so much, Bart. There were a lot of exciting takeaways there. I hope the attendees were able to learn something from this, both about this specific project as well as some of the general takeaways for embarking upon their hydrogen journey, if that is something that an attendee is trying to do. And good to know that there's resources out there to help them. It's also super exciting from the RD&D perspective that capacity is going to be producing a second generation of this truck commercially, because that's ultimately what the goal is of SoCalGas RG&D, is to help develop and demonstrate new technologies that can ultimately be commercialized and help our customers decarbonize. So that was super exciting to hear, and thank you for your presentation. So let's jump into these questions. There's quite a few. Most of them seem pretty quick though, so I think we should be able to get through them quickly. And again, to the attendees, if you have any questions, feel free to throw them into the question tab in the toolbar, or raise your hand. I don't believe there's any raised hands currently, so we'll just go through the ones in the toolbar really quick. First question, can the video on the trucks within the port be shared? I can answer that, yes. It's on YouTube. If you just go to YouTube and search ZCAP, it comes up at the top, but we can also put that link into the chat. And then second is, what percentage of the trucks at the port are Class 6 versus Class 8? And what class truck was developed for this project?
Well, okay, so I don't know if I can answer the question regarding Class 6 vehicles. I guess that information can be extracted from the annual reports and the equipment inventory at the Port of LA or Port of Long Beach. All of the ports, they publish annual inventory reports. So I think that question can be answered through that. I'm sorry, I don't have that offhand. Now this vehicle, that was considered a Class 8 truck. However, yard tractors, they are designed to handle much heavier loads than what you see in on-road applications. So, with on-road, you have gross combined vehicle weight limit of 80,000 pounds, and this one could pull over 200,000 pounds if needed.
Okay.
I hope that answers the question.
If it doesn't, they can certainly follow up. I know who asked the question. And then next question is, how often does the H-Tech dispenser need to be refilled?
Okay, so that's a great question. So typically, and there's some math involved there, with cascade fuelers, on average, you can you have about 60% usable volume. So, if we had 180 kilograms of storage on site, that means we can effectively dispense about 60% of that volume, which that is about 10 truck fills. So now, depending on the usage and the duty cycle, after every 10 vehicle fills, a hydrogen has to be delivered to the site. So if we had both trucks running 2 shifts a day, that's 2 fills a day. So probably every 5 days, the hydrogen would have to be delivered to site.
All right. And what are the onboard storage tanks made out of? Is it carbon fiber?
Yes. These were Type 4 tanks, so they were polymer liners and carbon fiber overwrap.
Okay. And I think you kind of just answered this, but what percentage of the 182 kilograms of on-site storage is usable?
Yeah, it's about 60%. Again, this is where it gets tricky. If the cascading fill procedure is executed properly, so switching the banks, we found that to be problematic with the operators, and it did not always work as designed.
All right. And then probably can't answer this next one, but I'll ask it anyways. What was the cost of the H-Tech storage and dispenser?
Oh, these questions are always hard because we're talking about prototypes, right? And these things are not cheap, and there's cost of design. testing rolled into it. So at a risk of getting in trouble here, I think it cost us, again, for this demonstration and prototype build, I think it was over $1 million overall. But my expectation is that if it was built in multiple quantities, that cost would have been much lower.
Right. Yeah, that makes sense. How did you get power to the H-Tech fueling station?
That's a good question. We did find a lucky light pole nearby that we tapped into. We found some 120 volts there, so we had to add an electric sub panel and run 120 volts to the fueler there.
Wow, that's convenient.
Well, it was an unexpected permitting and design process, though, because it was treated as a construction permit, and we had to bring an electrical inspector there, so that cost us some time.
Gotcha. How many trucks were demonstrated?
2 trucks.
All right, easy one. Did you conduct a survey with the longshore workers to get their opinions on driving the trucks?
We did multiple attempts of surveying the workforce. We did have some challenges there with engagement due to ongoing collective bargaining agreement negotiations. And for those of you working in a organized workforce environment, it can get a little challenging. But we did conduct informal surveys and conversations with the operators. And again, those that drove the trucks, they loved them.
Good. So this next question actually came in before you covered it on your presentation, so I know it was answered, but I'll ask it anyways. And that's if the cascading of the storage banks was automatic, would that solve some or all of the issues experienced?
I think it would resolve a lot of them.
Okay.
If it was a single button operation, I think the experience would have been different, better.
Okay, it's good to know. And in another fueling question, instead of wet hose fueling, could a manifolded time fill dispensing system work, like CNG time fill?
Absolutely, it would. And we are big proponents of that solution. We've seen it work really well in the CNG industry. We know fleets that have adopted it and love it. It works. Again, it may not work for everyone, because that means you have to stop the trucks for a shift, right? They typically the time fill solutions, they run overnight, and they probably make sense if you have 20, 30, 50 trucks that you're trying to plug in. That's when it would make commercial sense. But yes, it would absolutely work. And we're hoping to see these types of solutions come up as we see more vehicles getting rolled out.
All right, sounds good. And sorry to the attendees, I got yelled at on the back end. We forgot to turn our cameras on.
Thank you,
last
Heather.
Slide got a little boring.
Thank you, Heather.
Yes. Let's see. We got a few more questions. Comment just says great trial, and then asks, what is the purity of the hydrogen going through the fuel cell?
Well, this is a automotive grade hydrogen, and there's standards required. Every manufacturer, fuel cell manufacturer, will have their own requirements for hydrogen purity. typically it's the 5 nines, so 99.999 pure hydrogen that meets certain quality standards that has to be supplied to the fuel cell.
Okay. And then next question was answered in the chat, but I'll answer it as well. And that is, when will this webinar be distributed for those who couldn't watch at this time? So the slides are already posted in GoToWebinar. You can access those, but the recording will be posted, I believe, later this week or sometime next week. So you'll definitely be able to view it and share it with friends and family and anybody who else is interested. Next is just a comment. I'm super excited about this tech. Yeah, so are we. Thank you. I'm glad to hear that. And then next question, can you share the slides? Yeah, again, they're in the handouts tab. But if you don't see them or for some reason you can't access them, feel free to reach out to me. My email is shown here on this slide and we can make sure to get those to you. Please clarify the kilogram capacity on the truck and verify the fills are at H35 pressure.
The nominal tank capacity is 9.1 kilogram, and they are 350 bar tanks, or the fills. Right. The fills are 350 bars.
Sure. Okay. And then, do you have plans for additional demos in the port?
We'd love to, absolutely. We love to help manufacturers. We love to help operators pulling demonstrations like this together. So
yeah, I'm not sure who asked this question, but if you're interested, reach out to me, reach out to Bart, and let's see if we can make something happen, because it's definitely of high interest for both of us.
And there's funding opportunities exactly for port demos like this one. So again, we can definitely help.
All right, last two questions. Why did you choose gas hydrogen over liquid?
Well, 5 years ago, I don't think we had any options, any other options. Even the pressure, we went with 350 because 700 was pretty much limited to light duty vehicles, and it's more complex and probably would not stand up well to industrial operation. We do see liquid hydrogen getting more attention nowadays, both in terms of distribution, storage, and onboard storage. There's exciting work, research and demonstration work going on, and we expect that in a few more years, we might start seeing some early pilots on the road.
Yeah, that's exciting. And then last question, unless a couple more come in or some folks have their hands raised, which I don't see, is what was the carbon intensity of the hydrogen used?
We don't have that information on hand. It was
you set
really
yourself
difficult.
Up for that one, Bart.
I know. So I guess maybe I will answer in a roundabout way. According to a CARB study, I think a couple of years ago, the hydrogen that's used in California for transportation purposes is over 90% renewable. So maybe not a numerical answer, but the hydrogen that is being used in transportation in California is pretty clean.
All right. And then it does look like we have one hand raised. I'll see if I can figure this out. Antonio Gomez, I'm going to unmute you. And feel free to unmute yourself on your end to ask your question.
Hey, Jeff and Bart. Can you guys hear me?
Yes.
Awesome. Yeah, so thanks for all the information. I was just wondering from a like powertrain control strategy, since it does have an 85 kilowatt hour battery and the fuel cell on board. How do you decide the strategy, or how is that decided between, is it just full battery feeding the motors, or is it deciding between fuel cell or batteries?
That's a great question. Now we're going to deep dive into engineering. So since we had pretty large battery, the powertrain was set up as kind of battery dominant, and the fuel cell was operating as a range extender. So the battery was really providing most of the tractive effort energy, and the fuel cell was just keeping it at a healthy state of charge. I guess one benefit of that is that we could run the fuel cell in an optimum efficiency range. That's why we had those efficiency gains, right? Because the fuel cell was running at part load where they're the most efficient and continuously without going through transients.
That makes sense. All right, thank you.
All right, it looks like that's all the questions we got, Bart. We do have, oh, no, one more came in. Do the trucks have a CCS charge port?
They do. They do. However, it's not intended as a day-to-day operation. It's really more as a service tool. You know, if the truck is coming into the shop and it needs to be, the batteries need to be topped off, or the fuel cell is out, it's really just a service feature.
All right, great. And then I think we'll wrap up with the last comment that came in just before that last question, and it was just great presentation. Thank you.
Thank you.
You're welcome, Mark, and I agree. Yeah, thanks, Bart. Appreciate you presenting on this exciting project, especially since now that it's been wrapped up. So with no other questions, I think we'll wrap things up. Again, thanks to Bart for presenting, and thanks to everyone for attending and for all your great questions. Like mentioned, the recording will be available on our website soon, so be sure to check our LinkedIn for an update when it's ready. It should be in the next week or two. As an attendee, you'll also be receiving a survey request in your inbox soon. So if you wouldn't mind, please taking a moment to fill that out. Your feedback will help us improve future webinars and help us select topics that are of interest to all of you. And then also to remember that at SoCalGas RD&D, we really strive to identify transformational energy solutions, build them, and share them with you and the world. So thanks again, everyone. I appreciate your attendance. I hope you all have a good day. Thanks, Bart.
Thank you, Jeff, and Heather. Thank you for keeping us on track here.